Hello students, welcome once again to our channel Score High to Soar High. In this video series, we have been uploading Tamil Nadu State Board Syllabus Class 12 Physics Unit 2 Current Electricity Physics Derivations. That is 5 mark question and answers. Today in this video, we are going to see the fourth question. This is the part 4 of this video series. Come on, let us continue with our studies. Question number 4. Explain the determination of the internal resistance of a cell using voltmeter. Before that, let us learn the differences between EMF and voltage. What is EMF and what is voltage? EMF is the potential difference between the terminals of the battery or a cell in an open circuit, whereas voltage is the potential difference between the two terminals of a battery or a cell in a closed circuit. In other words, EMF is the potential difference in an open circuit. Voltage is the potential difference in a closed circuit. This is the differences. So by keeping these things in mind, let us continue with our studies. Here comes the diagram. Have a closer look at it. Here is a cell and here is a voltmeter, and this is nothing but the resistance of the cell itself. It is written as small r. This is nothing but the internal resistance of a cell. Now the second diagram, in the second diagram the same thing is there, but here in addition to all the components in the first diagram, here we have inserted another resistance which is written as capital R. So after drawing these two diagrams, we need to write the following things. Answer: the EMF of cell E is measured by connecting a high resistance voltmeter across it. The EMF of cell E is measured by connecting a high resistance voltmeter across it. Since the voltmeter draws very little current for deflection, the circuit may be considered as open. Here what kind of a voltmeter it is? A high resistance voltmeter. So it doesn't allow large amount of current to flow through it. So this voltmeter draws very little current only for its deflection. So even though this circuit is a closed one, this circuit may be considered as open. So in an open circuit, what can we measure? EMF. Hence, the voltmeter reading gives the EMF of this cell. So in this case, whatever the reading we get it from this voltmeter, that gives the EMF of the cell. When an external resistance R is connected, current I passes through it. When an external resistance R is connected, current I passes through it. Now what will happen? A potential drop occurs. So the potential drop across the resistor R is V is equal to IR. Let us consider this as equation number 1. Now due to internal resistance of the cell, the voltmeter reads a value V which is less than the EMF of cell E. Now, after connecting a external resistance, this circuit may be considered as a closed one. So now we can measure the voltage. Now, due to the internal resistance small r of this cell, the cell itself offers a kind of resistance to the flow of current. Therefore, the voltmeter reads a value V which is less than the EMF of this cell E. So we can write the equation like this. V is equal to E minus IR. So from this equation itself we can understand clearly this voltage is lesser than the EMF itself, because V is equal to E minus IR. So definitely V is less than this E. In the next step, I have interchanged the terms. The term at the right hand side, I have brought it to left hand side, and the term at the left hand side, I have brought it to the right hand side. In the next step, minus IR is equal to V minus E. In the next step, I have changed the signs. So plus IR is equal to minus V plus E. In the next step, therefore IR is equal to, I have brought the plus term first and then minus term next. So IR is equal to E minus V. Let it be equation number 2. Now divide equation 2 by equation 1. We know IR is equal to E by V is the equation 2 and V is equal to IR is equation 1. So while dividing equation 2 by equation 1, we get IR by I capital R is equal to E minus V by V. Here I and I get cancelled. So we get small r by capital R is equal to E minus V by V. In the next step, what will happen? While keeping the small r as it is, if we bring this r over here, it will become multiplied. Now, small r is equal to E minus V by V into capital R. So we have got the final expression as small r is equal to E minus V by V into capital R. If you happen to forget how to derive this equation, you better write down this final expression at least, and you may get mark accordingly. Since E, V and R are known, internal resistance small r can be determined. Actually, this EMF is indicated by the Greek letter eta, but it is somewhat complicated to write down the symbols. So instead of eta, in some books they have used this symbol. So it is also used in our derivation. So with this video has come to an end. Let us continue our studies with another equation in the next video.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.